Something is hiding in the universe. A region so unnaturally cold, so impossibly empty, that even the laws of physics seem hesitant to enter it. Astronomers found it by accident. Cosmologists tried to explain it away. But the deeper they looked, the stranger it became. Because the cold spot isn't just cold. It might be evidence of another universe touching ours. And if that's true, then everything we know about reality is wrong. The discovery that should have been impossible. When NASA's WMAP spacecraft first mapped the cosmic microwave background, the faint afterglow of the Big Bang, scientists expected something smooth, predictable, almost boring. Tiny temperature fluctuations, yes, but nothing extreme. Then something unbelievable appeared. A massive circle, nearly 1 billion light-years wide, far colder than the surrounding universe, a region that defied every simulation. At first, the team assumed it was a glitch, software error, faulty calibration, cosmic dust, anything but real. So they checked again, then again, then again. Every time, the cold spot was still there, sitting like a cosmic bruise on the face of the universe. When the European Planck satellite launched years later with even better accuracy, many scientists believed it would erase the anomaly. But Planck confirmed it with terrifying precision. This thing was real, and it wasn't supposed to exist. Why this cold spot terrifies cosmologists. The universe on large scales should look similar everywhere. The CMB is like thermostatic, random, evenly spread noise. Yet the cold spot is too big, too deep, too structured to be random. It violates the rule book. Imagine heating water on a stove. You expect a smooth temperature, warm everywhere. But suddenly, one spot becomes ice cold, while everything around it stays hot. You wouldn't call that random. You'd say something caused it. That's the cold spot. Its size alone, roughly 1.8 billion light-years across, breaks statistical probability. If the early universe expanded evenly, nothing this extreme should be possible, unless something interfered, something massive, something ancient, or something from outside our universe. The simplest explanation is a massive void, a region of space with fewer galaxies, less matter, and therefore less heat. And at first, this seemed plausible. Astronomers discovered a supervoid in the cold spot's direction, one of the largest ever found. But here's the problem. The void isn't big enough, not deep enough, not empty enough to create the cold spot we observe. The void would need to be 100 times stronger. That's like finding a scratch on your car and realizing the damage was supposed to be a crater. The numbers don't add up. So, If the void can't explain it, what can? The multiverse collision theory. This is where the story stops being safe. Some physicists believe the cold spot is a scar, the mark left behind when our universe collided with another bubble universe during cosmic inflation. Think about it. If the universe expanded from a quantum foam of bubble universes, occasionally two might brush against each other. When that happens, the overlapping region leaves a signature on the cosmic microwave background. Something circular, something colder than the rest, something suspiciously like the cold spot. This isn't sci-fi. This is a legitimate cosmological model. It suggests multiple universes exist. They expand like bubbles in a cosmic ocean. Collisions leave observable scars. And if the cold spot is one of those scars, then humanity has already seen evidence of another universe. Why scientists fear this theory? Because if the cold spot is a collision mark, then physics isn't universal. Our universe is not alone. Reality might have boundaries. We may be inside a bubble that once touched something else. The implications are enormous. It would mean the Big Bang wasn't the birth of everything, just the birth of our bubble. And somewhere out there, far beyond any telescope, another universe might still be expanding, still evolving, still existing, possibly with different laws, constants, dimensions. This is not comfortable territory for physics. The dark flow connection. In 2008, scientists found that entire galaxy clusters spanning billions of light years were moving in the same direction at incredible speeds. Something was pulling them. But nothing inside our universe could explain the motion. Some theorists connected this phenomenon to the cold spot. If another universe exists beyond the observable boundary, its gravity might create dark flow. Entire regions of space might be drifting toward the unseen mass. It's speculative, controversial, but it fits. The universe may be influenced by something beyond its edge. Here is the uncomfortable truth. Every explanation for the cold spot is improbable. It's too big to be random, too deep to be a normal void, too structured to be noise, too stable to be an illusion. So scientists are left with a mystery that resists every answer, except one. The cold spot might be the first observable imprint of another universe, a cosmic fingerprint, a silent collision, a message written in microwave radiation from 13.7 billion years ago. We may never be able to cross into that universe. We may never know what lies inside. But the evidence hints at something profound. We are part of a much larger reality, where universes are born, collide, and vanish like sparks in an infinite dark. The cold spot is not just a temperature anomaly. It is a reminder that the universe we see might be only the beginning.